Our next lesson is the Galosha Method. The method of Gelosia is used in the application of multiplication. Gelosia originated in India and much of our arithmetic. It first appeared in Hindu works. In India, this ancient multiplication approach is called the quadrilateral. From India, this method spread to Chinese arithmetic in 1593. This method also spread to Persia and the rest of the Arab world. It was especially popular in Arabia and Persian works. In Arabia and Persia, it was called the method of the sieve or the method of the net. As for the operation of this method, the Galosha method is completed as follows. First, a large square is drawn if the number of digits in your multiplier is the same as the number of your multiplicand. And a large rectangle is drawn if there is an equal number of digits to be multiplied, meaning the number of boxes varies depending on how many digits are in the numbers being multiplied. The number of digits in each number you are multiplying corresponds to the number of squares you need to divide the large number into, or the large square into, rather. For example, if one was multiplying 45 by 39, one would need to construct a large square divided into 4 squares. The 2 by 2 square box is the foundation for the grid-like method of Gelosia. An example of 3 by 3 box to multiply 3-digit numbers is shown in Wolfram Math World website, and it looks like this. Next, each square is diagonally split in half, with the diagonals extending outside the box. This crisscross look gives the appearance of a lattice-looking diagram. To continue, the first number is written across the top, while the second number is written down the left-hand side. To begin finding a product, the first left upper-hand box is looked at. The numbers on the corresponding row and column of the box are the ones that are multiplied. For instance, when multiplying the numbers in the diagram, 948 by 827, the upper left-hand box would correspond to the numbers 9 and 8. These two numbers are multiplied, and the partial product would be placed into the box. However, being diagonally split helps establish place value in the box. In this case, 72 would be written with the 7 on the left side of the diagonal and the 2 on the right side, representing the ones place. This same method is then performed for each of the remaining boxes. 4 times 8, that's 32. 8 times 8, that's 64. 9 times 2, that is actually 18. 4 times 2 is 8. 8 times 2 is 16. 9 times 7 is 63. 4 times 7 is 28. 8 times 7 is 56. Once the multiplication is completed in each of the boxes, the operation of addition is performed. The diagonals in each box create diagonal stripes in the diagram. These diagonal stripes are added starting with the right one. The numbers that are included in the diagonal stripes are added together. The sum is written at the bottom of the diagonal stripe outside the box. This is done for each diagonal stripe in the diagram. The sums of each stripe will be written from right to left across the bottom and then up along the left side of the box. The numbers read from going down the left side and across the bottom make up the product to the answer. The lattice arrangement of this method also effectively takes care of place value, with the right diagonal stripe being the ones column, followed by the tens, hundreds, and etc. So we'll start here. This is 6. 6 plus 5 is 11, plus 8 is 19, carry 1. 1 plus 4 is 5, plus 1, 6, plus 8, 14, plus 2, 16, plus 3, 19. Carry 1. 1 plus 6, 7, plus 2, 9, 9 plus 8, 17, 17 plus 6, 23. Carry 2. 2 plus 3 is 5, 5 plus 2 is 7, plus 1 is 8, and 7. Therefore, the product of 948 times 827 using Galosha method is 783,996. That's 783 and 996. Overall, this method, although the explanation seems complex and lengthy, is actually very simple to understand and use. The organizational element of the lattice arrangement allows for large multiplication problems to become a lot of small, basic ones. Overall, the method of Gelosia is a simple and fascinating technique used to demonstrate the understanding of number sense from ancient India all the way to the present day. This method allows users to visually focus on the steps of multiplication and turn complex multi-digit problems into smaller, simpler multiplication problems.